So we're now going to talk about how to apply these basic Java CompletableFuture features. And we'll show this in the context of our running example using big fractions, which are arbitrary precision, big fraction arithmetic, just because it gives us something fun to work with. And we're going to take a look at some source code, and we'll also visualize what's going on here on the right-hand side, as we mentioned before. And as always, you can get this from my GitHub repository, this time in the EX8 project, in the Java 8 folder, in the Live Lessons GitHub repository. We'll also summarize some of the downsides or the limitations with these basic features, because they don't do very much, which of course is what motivates everything else that comes with the CompletableFutures API. So here's the example. And again, left-hand side is the code, right-hand side is the interaction diagram. I'll try to keep them in sync as I talk through this. So the first thing we do is we create an incomplete future. So this is like the donut without the hole, doesn't have any value associated with it, and that's equivalent to creating a new completable future, as you can see here on the right-hand side. The next thing we're going to do is we're going to start a thread. This is an anonymous thread, just a good old Java platform thread or traditional thread. And we're going to start this to run a computation in the background. So you can see that we make a new thread and we start it. And of course, you all know when you start a thread, it calls its run method. We don't specifically have a run method because we're going to be using a supplier lambda, but same basic idea. The supplier lambda that we're going to give here is going to take two big fraction objects, and it's going to multiply them together. And remember, big fraction's an arbitrary precision fraction that uses big integers, which are arbitrary precision integers, as the numerator and denominator. So we're going to take these two big fractions, and we're going to multiply them together. And then you'll see this computation here inside this thread is going to run concurrently with respect to whatever we have here, dot, dot, dot. I left this out, but it could be whatever you wanted to put there. So those two things will run in parallel. You can see here in the interaction diagram, that's indicated by two different threads that are running at the same time. Then what we're going to do is we're going to explicitly complete the future with the result. So we're going to multiply the two big fractions together, and then we're going to give that future that value via its complete setter method, and that will then complete the future, gives it the donut hole to the donut, and all is well. Now, this call here to join, which is in the main thread, will block until this background computation finishes. And after it's done, it'll print the results out as a mixed string. So that's basically the way in which this program works. So pretty straightforward, but it has some limitations. So let's talk about some of the limitations. So as we had alluded to a while back, there are some limitations with future and completable future using only the basic features, which really come from future, don't do much to improve anything. So you still can't chain anything fluently to handle the results asynchronously or results of asynchronous computations. You can't trigger this thing reactively. You can't treat this efficiently as a collection of futures or completable futures and so on and so forth. So pretty much everything we talked about before that were limitations with future are still limitations with the basic features of completable future. Another problem we see here is we're using a blocking call to join, which underutilizes cores and increases overhead. So try to avoid this whenever possible. You only want to call join when you absolutely have to get the result. And in fact, for your programming assignment number 4, you'll see that there's only one place where you actually call something to get the result. Moreover, if you add in a get call here, then you're really not solving the problem. You're just pushing it down the road a bit. And you'd also have to update this code to use a try-catch block or exception laundering or something. I think exception laundering won't even help you here because this has to actually pass parameters. So not really the best thing to do. And it says here, timeouts with Java 8 completable future, you're probably doing it wrong, which is probably correct. Therefore, we're going to need to leverage the advanced features of completable future, which of course is what we're going to talk about next. And those advanced features, as you may recall, are the ones that use all those other cool capabilities. So things like the factory methods, things like the completion stage methods, things like the exception methods, the arbitrary arity methods. Those are the things that go, those are the capabilities of completable future that go above and beyond what we get out of the box with the basic features. So that is what we're going to talk about next.